In the summer of 2003, humanity loaded its curiosity into a metal box the size of a golf cart and fired it into space. That machine was Spirit, and even before it left Earth, it carried the weight of one of the oldest questions our species has ever dared to ask out loud. Are we alone? The rover was not born from a single idea. It was the product of an enormous scientific ambition funneled through NASA's Mars exploration program, a program built around 4 guiding goals that would shape everything Spirit did, every rock it touched, every image it sent home across 142 million kilometers of empty space. Those goals were to determine whether life had ever existed on Mars, to characterize the Martian climate, to understand the planet's geology, and to prepare the ground for human explorers who would one day follow in the rover's wheel tracks. Spirit was designed to be the instrument through which some of those answers might come. So what exactly was this machine? At roughly 185 kilograms, Spirit was a compact and remarkably capable geological field station. It carried panoramic cameras and navigation cameras. A miniature thermal emission spectrometer allowed it to examine rocks at a distance and determine their likely origins. 2 hazard avoidance cameras kept watch over the terrain around it. And on the rover's extendable arm, there was a suite of contact instruments, a Mössbauer spectrometer and an alpha particle X-ray spectrometer for studying the mineralogy of rocks and soils in detail, a microscopic imager for close-up photography of surface textures, magnets for collecting dust samples, and the rock abrasion tool, a diamond-tipped grinder that could expose fresh, unweathered rock material for examination. Each of these tools existed for one reason. Scientists cannot yet stand on Mars themselves. Spirit was their hands, their eyes, their laboratory. Everything the rover touched or photographed was data flowing back to Earth and into the minds of researchers trying to reconstruct a planet's history from stone. The rover was originally known only by its mission designation, MER2. Its name came later, and it came from a child. A 9-year-old girl named Sophie Collis had grown up in a Siberian orphanage before being adopted by an American family. When NASA held a student essay competition to name the 2 Mars rovers, she wrote, "I used to live in an orphanage. It was dark and cold and lonely. At night, I looked up at the sparkly sky and felt better. I dreamed I could fly there. In America, I can make all my dreams come true. Thank you for the spirit and the opportunity." A rover named by a child who had once looked up at those same stars. There is something fitting about that, given what Spirit would go on to face. The launch came on June 10th, 2003, from Cape Canaveral, Florida. Spirit departed Earth first, ahead of its twin rover Opportunity. After entering a brief parking orbit, the upper stage of the payload assist module fired, sending the spacecraft onto a heliocentric trajectory calculated to intercept Mars. It would take nearly 7 months. During that time, 4 separate course corrections refined its path until, on January 4th, 2004, Mars finally filled the cameras and the most dangerous phase of the entire mission began. There is a reason NASA engineers have a name for the landing sequence. They call it the 7 minutes of terror, though for Spirit, the ordeal lasted closer to 6. It is the window of time during which a spacecraft traveling at nearly 19,000 kilometers per hour must be brought to a complete stop on the surface of another planet, using only a heat shield, a parachute, a set of retro rockets, and inflatable airbags. No human on Earth can intervene. The onboard computer makes every decision itself, in real time, with no margin for error. Spirit hit the upper atmosphere of Mars at that blistering speed. The aeroshell protecting it climbed to 1,600 degrees Celsius on its outer surface, while the interior remained at room temperature. 15 minutes before atmospheric entry, the spacecraft's cruise stage had separated, leaving only the lander inside its protective shell to fall alone. At an altitude of roughly 5 miles, the craft slowed to around twice the speed of sound, and the parachute deployed. 30 seconds later, the lower section of the heat shield was jettisoned. 10 seconds after that, Spirit's lander began to unspool on a tether at 70 meters per second, dropping toward the surface while the parachute continued to slow the descent. Radar began painting the terrain below. The onboard computer calculated the moment the retro rockets would need to fire. 5 seconds before impact, the airbags inflated around the lander in every direction. The retro rockets ignited, bringing the descent speed momentarily to zero. At roughly 8.5 meters above the ground, the tether was cut. Spirit fell, hit the Martian surface, and bounced. Then bounced again, and again, nearly 30 times in total, rolling across the crater floor before finally coming to rest roughly 250 meters from the point of first contact. EDL was complete. The 6 minutes of terror were over. Spirit was on Mars. The landing site was not precisely where the team had aimed. It was around 12 kilometers from the planned target zone, but it sat inside Gusev crater, a 166-kilometer wide impact basin that scientists believed may once have been an ancient lake. The Ma'adim Vallis, a Martian outflow channel more than 700 kilometers long and far larger than Earth's Grand Canyon, was thought to have once emptied into the crater. If any water had ever pooled on the surface of Mars, Gusev was one of the most promising places to look for its legacy. Spirit was in the right place, but it would not stay there quietly for long. The landing site was named Columbia Memorial Station, in honor of the 7 astronauts lost in the Space Shuttle Columbia disaster earlier that year. The hills visible on the horizon were named for those same 7 crew members: Anderson Hill, Brown Hill, Charler Hill, Clark Hill, Husband Hill, McCool Hill, and Ramon Hill. Spirit's mission had barely begun, and already it carried that memory with it. 16 days after landing, with the rover just beginning its first cautious explorations of a shallow nearby depression called Sleepy Hollow, the mission nearly ended before it had truly started. Contact with Spirit was lost. Engineers at NASA's Jet Propulsion Laboratory received only a faint signal back, enough to confirm the rover was alive but unable to function normally. It was stuck in a loop, rebooting itself over and over, too deep in a fault cycle to respond to commands. The team worked without sleep to diagnose the problem. The culprit turned out to be a combination of a corrupted file system and a software flaw that caused the rover to reboot whenever it detected an error during its own reboot process. An infinite loop, a digital trap. The fix required reformatting the rover's flash memory entirely from Earth, across interplanetary distances, with no physical access to the machine. They succeeded. On Sol 32, Spirit came back online. The mission could continue. Mars does not give up its secrets willingly. It layers them in stone, buries them in dust, locks them beneath weathered surfaces that have been exposed to cosmic radiation and temperature swings for billions of years. To read those secrets, Spirit needed to get close. Very close. The rover's first significant geological target was a rock about the size of a football, sitting not far from the lander. Named Adirondack, it had a relatively flat, dust-free surface and a geometry that matched the rock abrasion tool's requirements well. Getting to it required a series of careful movements. Short arcs, slight turns, then a direct approach. In the rock-strewn terrain of Gusev, nothing was taken for granted. Before grinding into its surface, Spirit's instruments recorded Mössbauer spectrometer readings from the untouched exterior of Adirondack. These were the first readings of their kind ever taken on Mars or on any other planet. They suggested the rock contained magnetite, olivine, and pyroxene, minerals associated with volcanic basalt on Earth. On Sol 34, Spirit used the rock abrasion tool to cut into Adirondack, drilling a borehole 45 millimeters wide and 5 millimeters deep. The diamond-tipped wheel spinning at 3,000 revolutions per minute consumed around 30 watts of electricity to expose fresh rock on another world for the very first time. What Spirit found inside confirmed the mineralogy. Adirondack was a picritic basalt, similar to ancient volcanic rocks found on Earth, but it had been slightly altered, the surface touched in some minor way by thin films of water that had promoted mineralization. It was a faint trace, a whisper, but it was there. A few weeks later, Spirit arrived at Humphrey Rock, a darker volcanic boulder about 60 centimeters tall. After scraping away just 2 millimeters of its outer surface, the rover revealed bright material filling the rock's interior cracks. The shape and distribution of this material pointed to minerals that had crystallized out of water. Either water had worked its way into Humphrey after the rock formed, or it had been present in the environment when the rock solidified. Either way, Mars was speaking and Spirit was listening. On Sol 65, the rover reached Bonneville Crater, where its own heat shield lay discarded from the landing. The crater was 210 meters across and reasonably intact, but the science team found no compelling rock targets along its rim, and the rover did not descend. Instead, Spirit turned toward the Columbia Hills, visible from the landing site, and began its long traverse across the open plains of Gusev. It was during this journey that the first signs of mechanical wear appeared. Spirit's right front wheel began drawing significantly more electrical current than its counterparts, a sign that something inside the wheel mechanism was resisting rotation. The cause was uncertain. Debris lodged in the gearing, perhaps. Lubricant that had congealed. Spirit's engineers began managing the wheel carefully, using it less, occasionally reversing the rover's direction entirely to reduce the stress on the motor. These workarounds, simple in concept but requiring precise planning and execution, are part of what made Spirit's extended survival possible. The team introduced one of their most effective improvisations. They began driving the rover backwards, dragging the compromised front wheel rather than forcing it to push. A small change, an enormous difference. By Sol 159, Spirit had reached the Columbia Hills and began climbing. The Columbia Hills are not mountains. Husband Hill, the tallest of them, rises about 107 meters above the surrounding plains. But for a rover with 6 wheels, at least one of which was increasingly unreliable, operating on reduced solar power as Martian winter approached, climbing that hill was a meaningful undertaking. Spirit spent months working its way up through the rock-studded slopes, pausing to examine formations that told the story of a more geologically complex Mars than anyone had expected. A rock named Clovis, found on the Columbia Hills, turned out to contain unusual levels of minerals associated with aqueous alteration. Another, named Wishstone, had a composition unlike anything else discovered on the plains below. The hills were not the basaltic monotony of the Gusev plains. They were something older, something more complicated. On Sol 420, a dust devil swept over Spirit and cleaned the accumulated grit from its solar panels. In a single pass, solar panel efficiency jumped from roughly 60% back to over 90%. Mars had, in its own indifferent way, given the rover a second life. The mission team made use of every watt. Spirit reached the summit of Husband Hill on Sol 581, becoming the first rover to climb to the top of a hill on another planet. From the summit, the team assembled a sweeping panorama composed of 653 individual images, the first panorama ever taken that included the full deck of the rover itself. The distant peaks of McCool Hill and Ramon Hill sat on the horizon. Spirit had earned the view. On the descent, the rover was directed to examine a rock named Comanche, and the results were remarkable. Laboratory analysis of the data showed that Comanche contained roughly 1/4 magnesium iron carbonates, 10 times more than any previously examined Martian rock. Carbonates form in the presence of water, but only water that is relatively neutral, not highly acidic. Their discovery in such quantities was significant. It suggested that at some point in Mars's past, bodies of water had existed with chemistry that could, in principle, have supported primitive life. Then came the accident that turned out to be a discovery. By March 2007, Spirit's right front wheel had failed completely. The rover was now dragging it, leaving a furrow in the soil wherever it moved. As the wheel carved through the surface near a feature called Home Plate, a plateau of layered rock, it exposed a bright patch of material just beneath the surface crust. The team directed Spirit to stop and examine it. The bright material was silica, nearly pure silica, at concentrations far higher than anything else found in the Gusev region. The same concentrations found in 2 very specific environments on Earth: hydrothermal systems, where hot water dissolves silica in one location and deposits it in another, and fumaroles, where acidic volcanic gases strip minerals from surrounding rock and leave silica behind. Both of these environments support microbial life on Earth. Hot springs and fumaroles are among the candidate sites for where life on this planet may first have taken root. Spirit had not found life. but it had found the chemical fingerprint of the kind of place where life might once have thrived. Had the front wheel never failed, had Spirit been able to drive cleanly over the surface without gouging it open, that silica patch would have stayed buried and unknown. The malfunction was the discovery. Every machine eventually stops. The question is, what it leaves behind. Spirit's final months were defined by the same combination of ingenuity and attrition that had marked the entire mission. By 2009, the rover was generating only around 128 watt-hours per sol, less than the 150 watt-hours it needed to keep its internal heaters running. Martian winter was pressing in. The skies were thick with dust from a series of major storms, blocking most of the sunlight that Spirit depended on. The rover had managed 3 Martian winters already. The 4th would be different. On Sol 1892, Spirit drove into a patch of soft soil near a feature called Troy. Underneath the rover's wheels was jarosite, an iron sulfate mineral with almost no cohesion. The wheels spun and found nothing. The rover was stuck. Engineers at JPL spent months testing extraction procedures in a replica sandbox. Every technique they tried in the Martian soil simulation, they transmitted to Spirit. The rover tried them one by one. None of them worked. The soil simply would not hold. Spirit remained at Troy, tilted at a slight angle, its solar panels facing partly away from the winter sun. On Sol 2155, NASA formally reclassified the mission. Spirit was no longer a mobile rover. It was a stationary science platform. From that fixed position, it continued to take atmospheric measurements, sample the nearby soil with its arm, and transmit images. The arm, at least, still worked perfectly. The rover adapted to its new role without complaint. Winter deepened. Power generation fell. By Sol 2196, the rover was back at the critical threshold. A few sols later, it crossed below it. Sometime around Sol 2208, Spirit is believed to have entered a low-power fault, the automatic response to a battery too drained to maintain normal operations. The sequence of shutdown would have been quiet, systems going dark one by one in the correct order, the rover attempting to conserve enough power to wake up again when conditions improved. The signal never came. The last confirmed communication from Spirit arrived on March 22, 2010. After that, silence. NASA continued to send commands and listen for a response until May 2011. Nothing was received. The mission was officially declared over. In its 2,208 sols of operation, Spirit traveled 7.73 kilometers across the surface of Mars and returned more than 128,000 images to Earth. It was designed to last 90 days. It lasted more than 6 years. It was not built to survive Martian winters, and it survived 3. It was not expected to climb hills, and it reached a summit. It was not supposed to make major discoveries through mechanical failure, and yet the silica patch at home plate stands as one of the most significant finds in the history of Mars exploration, precisely because a wheel broke in the right place at the right time. Spirit's name lives on. The Perseverance rover, launched in 2020, carries the legacy of the entire Mars rover program forward on a planet that Spirit helped us understand. And somewhere in the Gusev crater, sitting motionless in the Martian soil near the edge of home plate, the rover still sits. It is dark there now, cold. The solar panels are coated with dust. The batteries are long dead. But the rocks Spirit drilled, the silica it exposed, the carbonates it measured, and the images it sent home have become part of a permanent record of humanity's curiosity. A record that will outlast the rover itself, and perhaps outlast all of us. Sophie Collis wrote that she used to look up at the stars from a cold, dark orphanage and feel better. Spirit looked back. If you love exploring the universe, I'm sharing a video about the mysteries James Webb discovered on Neptune. Like, subscribe, and share. See you later.